A production bug took my team 3 days to find. 3 days. We had logs everywhere. Structured JSON logs in every service. We had metrics, CPU, memory, request rates, error rates, all of it dashboarded in Grafana. We had alerts firing. We knew something was wrong, but we had absolutely no idea which of our 12 services was causing the problem. The bug turned out to be a timeout in a third-party payment gateway call that was cascading through 3 downstream services and causing intermittent failures that looked completely different depending on where you were looking. 5 hours into the investigation, someone suggested we check the payment service. It took another 2 hours to confirm it, then 1 hour to fix it. 3 days of engineering time for a one-line config change. The missing piece was distributed tracing. And the reason we didn't have it was that setting it up used to be genuinely painful. You had to pick a vendor, install their proprietary SDK, vendor lock your entire instrumentation layer, and pray that they supported all your languages. OpenTelemetry changed that. And today I want to tell you why it's become the standard, how it works, and how you can go from zero to full observability in your stack in a few hours. I'm Alex, and this is Bot Thoughts by AmtocSoft. Let's start with the fundamentals. Observability is a property of a system that tells you how well you can understand its internal state from its external outputs, and it's built on 3 pillars: traces, metrics, and logs. These are sometimes called the observability triad. You probably already know logs. Log statements are the print statements of production systems, events that happened with timestamps. Something went wrong, here's the message. A user signed in, here's the log line. Logs are great for understanding what happened at a specific point in time in a specific service. They're terrible for understanding what happened across multiple services in a single user request. Metrics are aggregated numerical measurements over time. Request count, error rate, P99 latency, CPU usage. Metrics are great for dashboards and alerting. They tell you something is wrong. They don't tell you why. Traces are the missing piece. A trace follows a single request as it travels through your entire system. When a user hits your API, a trace is born. That trace gets a unique ID. Every service the request touches records a span, a unit of work with a start time, an end time, metadata, and a link to the parent span. At the end, you have a complete picture of that request's journey: which services it visited, in what order, how long each step took, and where things went wrong. This is what we didn't have in my 3-day debugging story. With tracing, that bug would have been visible in minutes. We'd open the trace for a failing request, look at the waterfall diagram, see that the payment service span took 12 seconds when it should take 200 milliseconds, and immediately know where to look. The power of traces is that they give you context that neither logs nor metrics can provide on their own. Now, distributed tracing isn't new. Zipkin has been around since 2012, Jaeger since 2016. Datadog, Honeycomb, Lightstep, New Relic, Dynatrace, all of these had tracing solutions for years. The problem was fragmentation. Every vendor had their own SDK. Every SDK had its own API. If you instrumented your code with the Datadog SDK and then decided to switch to Honeycomb, you were rewriting all your instrumentation. Vendor lock-in at the observability layer. OpenTelemetry, OTel, solved this by separating instrumentation from backends. OTel is a CNCF project, the same foundation that houses Kubernetes and Prometheus. It provides a vendor-neutral SDK for collecting traces, metrics, and logs. You instrument your code once using the OTel API. Your instrumentation emits standardized telemetry data. You configure that data to go wherever you want: Jaeger, Zipkin, Datadog, Honeycomb, your own backend, doesn't matter. Switch vendors, keep your instrumentation. The industry rallied behind this incredibly fast. By 2024, OpenTelemetry was the second most active CNCF project by number of contributors, right behind Kubernetes. Every major observability vendor, Datadog, Dynatrace, Honeycomb, New Relic, supports OTel natively. Every major cloud provider, AWS, GCP, Azure, has first-class OTel support. The frameworks are adding auto-instrumentation: Express, Fast API, Spring Boot, Django, gRPC, database drivers, HTTP clients. You can get traces out of a Node.js application with literally 3 lines of code at startup. OpenTelemetry didn't win because it was forced on the industry. It won because it solved a real problem in the right way, at the right time. Let me make this concrete. How do you actually instrument a service? There are two layers to OTel instrumentation: auto instrumentation and manual instrumentation. Auto instrumentation is exactly what it sounds like. Most OTel SDKs have auto instrumentation packages for popular frameworks. In Node.js, you install at OpenTelemetry/auto instrumentations node. You add a few lines of setup code at the top of your entry file before anything else, and you configure your exporter. From that point, every incoming HTTP request creates a trace. Every outgoing HTTP call becomes a child span. Every database query gets traced. Every message queue interaction gets a span. You didn't write a single line of instrumentation in your business logic. It just works. The setup code looks like this. You create a Node SDK, you configure the resource, which is metadata about your service, like its name and version, you configure an exporter, and you call SDK, start. That's it. From that point, the SDK instruments your process automatically. Manual instrumentation is for the cases where you want to add context that the auto instrumentation doesn't capture. Maybe you want to trace a specific algorithm. Maybe you want to record which customer ID was involved in a request. Maybe you want to measure a batch job. For this, you get a tracer from the OTel API, you call tracer start span with a name, you do your work, you optionally add attributes, key value pairs with context, and you end the span. The OTel API is designed to be low friction. Adding a span to a function is about 4 lines of code. Adding attributes is 1 line. The API is consistent across languages. The TypeScript API looks similar to the Python API, which looks similar to the Go API. Once you learn it in one language, you mostly know it everywhere. Now, where does all this telemetry data go? The naive approach is to have each service send data directly to your observability backend. That works, but it has problems. Your services are now coupled to your backend's ingestion protocol. If you want to add another backend, say, you want traces in Jaeger and metrics in Prometheus, every service needs to know about both. And if your backend goes down or slows down, that can affect your application's performance. The OpenTelemetry collector solves this. The collector is a standalone process, a binary you run alongside your services or as a central aggregator in your cluster. Services send telemetry to the collector. The collector processes it and forwards it to one or more backends. The collector has a pipeline architecture with 3 stages: receivers, processors, and exporters. Receivers accept data in various formats. The OTLP receiver accepts the native OTel protocol. But there are also receivers for Prometheus metrics, Jaeger traces, Zipkin, StatsD, Fluent bit logs. Basically any existing telemetry format can be piped into the collector. Processors transform the data in flight. You can filter out sensitive attributes, strip passwords, credit card numbers before data leaves your infrastructure. You can sample high-volume trace data. You can batch records for efficient export. You can add resource attributes. The processors are a powerful middleware layer between your services and your backends. Exporters send data to backends. There are exporters for every major observability platform. OTLP exports to any OTLP-compatible backend. The Prometheus exporter exposes metrics in Prometheus format. The Jaeger exporter sends traces to Jaeger. The Datadog exporter sends to Datadog. You can have multiple exporters running simultaneously, fan out to several backends with a single configuration. The operational pattern most teams adopt. Each service exports to a local collector agent, which forwards to a central collector gateway, which applies sampling, filtering, and routing, and then fans out to backends. This decouples your application code from your observability infrastructure entirely. Let me paint a picture of what good observability looks like with OTel in place. A user reports that checkout is slow. Your on-call engineer opens your tracing UI, Jaeger, Honeycomb, Grafana Tempo, whatever you're using. They search for traces where the checkout endpoint took more than 2 seconds in the last 15 minutes. They get a list. They click on one. They see a waterfall. The API gateway, 10 milliseconds. The checkout service, 800 milliseconds. The inventory service call, 5 milliseconds. The payment service call, 1,400 milliseconds. That's where the time went. They click into the payment service span. They see attributes, which payment provider, which method, the response code. They see that this particular provider, let's call it provider B, has a P99 latency of 1.4 seconds, while provider A has a P99 of 200 milliseconds. This is a configuration issue. They look at the metrics dashboard, filter by payment provider, and confirm that provider B has been degraded for the last 2 hours. Total diagnosis time, 8 minutes. Not 3 days. This is not a fantasy scenario. This is what teams with good observability actually experience. The difference between flying blind and having full context is measured in hours of engineer time, sometimes days. That has a direct dollar value that is almost always larger than the cost of the observability tooling. You can't fix what you can't see. That sounds obvious, but most teams are still running with logs and metrics alone, trying to debug distributed systems with fundamentally inadequate tools. OpenTelemetry has made it easier than it's ever been to get full observability. Auto-instrumentation means you can get traces out of an existing node, JS or Python service in under an hour. The collector architecture means you're not locked into any vendor. The ecosystem is mature and the industry is fully behind it. If you're running any kind of distributed system, microservices, serverless functions, anything with more than 2 moving parts, and you don't have distributed tracing, this is the episode where I'd encourage you to stop, go open your service, and add 5 lines of OTel setup code this week. I'll have the full walkthrough with code on the blog, link in the show notes. This is Bot Thoughts by AmtocSoft. I'm Alex. Hit subscribe wherever you're listening, and I'll see you in the next episode.